Digital modes. Okay, station installation. If it's not black, we're going to just screen through it, okay? Or if it's not yellow. Current capacity requirements. All right, the mic picks up everything, so let's bring the current capacity requirements. What does my power supply need? That's just poorly worded. Consider the efficiency of the transmitter at full power output, okay? Receiver and control circuit power, the power supply regulation, and heat dissipation. So if you're transmitting, you're going to be generating more heat than if you're just listening. Use short, heavy gauge wires or a transceiver's DC power connection to minimize voltage drop when transmitting.
So what wire is good enough? I guarantee you the manufacturer's supplied cable
Yeah.
is the example you want to use when you make modifications.
Or bigger.
Because they intend for you to use that thing to its best potential.
Yep.
So don't ever go to a little less capable than what the manufacturer supplies.
Right. Okay, mobile installations. If you need help with a mobile installation, I have the hole saw to drill a hole in your car. So if you want it in, no, literally, I do. I have the 3/4 inch saw, and I used to build cop cars. I will drill the hole for you if you want me to, or you can borrow my drill bit if you want to do it yourself. There's some tricks to it, but somebody in the valley will help you with just about anything you want to try. Okay, power connections. 100 watt HF reg requires 20 amps or more and about 13.8 volts DC. Some of them are 22, okay, at least a 25 amp. Typical 50 watt mobile FM transceiver requires 13.8 volts at 12 amps. So what's this 13.8 volts thing? That's a properly charged, fully charged 12 volt battery. We call them 12 volts, but they're not. 12 volts on a 12 volt lead acid battery is half charged.
Well, you can only take it down to 10.
That's what the book says, 10 and a half. And that's-
Depending on the radio,
That's
some radios will shut off.
Yeah, you won't get that low. 50 watts, 13.8 volts at 12 amps. Connect both power leads directly to the battery with heavy gauge number 10 or larger wire. Okay, number 10. Now that's not 10, what do they call it? 10 gauge style
Yeah.
off of Amazon.
If
Or
it says
10
style, it's
anything,
automatically suspect.
if it's 10 anything other than AWG,
Right.
don't buy it unless you can read down in the
There's other choices. I'm not-
reviews that a ham radio operator is recommending. Okay? Don't buy the junk. They will send you 10 gauge style, and it's just fatter than a 10 gauge style from Home Depot, 10 AWG from a electronics store or something, but it's all insulation. And it's cheap, junky insulation. Okay? But it looks nice and fat, and it's not. And inside is aluminum wire, not copper. There's nothing wrong with copper-clad aluminum. It works, but copper's better.
Finely stranded copper.
Finely stranded is better than solid or coarsely stranded.
Way
It's
better.
more flexible. So, connect both power leads directly to the battery with heavy gauge, number 10 or larger wire. And I'll bet you the next one says put a fuse in each one. Fuse both leads at the battery. Both. I'm not sure why they want to do that. The only thing I can come up with is that if you get a short on either side, it's going to,
It's just simply faster.
yeah,
It's going to shut you off faster than allowing the radio to blow up.
Are you talking like positive and negative? or-
yes, yeah. Yeah, so you're going to have however you connect to the battery. I usually use a crimp ring and put it under the bolt. And then the shortest piece of wire you can get away with to get clear, and then a fuse holder, and then to run to your radio.
You'll typically see at least one fuse, and it's usually in the positive
Your radio, when it comes, the wire.
We'll have two.
Will have two fuses. And I have blown both fuses.
You want to. You want to. And they're cheap. You can buy a 10 pack for $10 or $12, depending on how big. I always buy the big, fat, heavy ones. And then they'll take a small fuse, no problem. The fuse is the safety link, not the thickness of the wire. Okay. Do not use the cigarette lighter socket. It's black. That's not written in stone. I use it in my F350 because I have a 25 amp cigarette lighter. It's a power outlet. But it won't work for HF while I'm driving because there's too much computer noise.
a small radio that's 25-watt radio.
Yeah.
and it works.
There are radios that are designed to plug into your cigar lighter, okay? If it's FM, it'll probably work fine, but if it's an HF or an AM, it's probably gonna get noise in it, so.
And one of the things that you can do to discriminate good socket from bad socket is read the owner's manual on your car. If it calls it an accessory socket, the odds are really good it's fused with 10 or 15 amps. If it calls it a cigarette lighter, it's fused with 4 or 5.
Which, I don't think they sell one anymore that has a.
I don't think so either, but you never know.
No, I know.
Read the manual, RTFM. You guys all
Yeah.
remember that one, right?
Okay, do not use a cigarette lighter socket. Yes, okay, so, the part to take away, negative power return should be connected at the 12-volt battery chassis ground. To me as a mechanic, that means to the side of the engine or the frame, but we all just go straight to the battery, but that's the answer to the question. Okay? All right, antenna connections. Antenna is significantly shorter. Antenna is significantly shorter than a quarter wavelength, especially on lower bands. The entire vehicle becomes part of the antenna system. Pay attention to every detail. Use most efficient antenna possible. Solid RF ground connections to the vehicle body. So a mag mount, you bought an F-150. I'm not
Yeah.
sure it was just the 150. If you bought a Ford pickup with an aluminum body, you can't use a mag mount.
It's just, the F-150.
That's the only aluminum one? Okay, you can't use that. You have to screw it onto something. It's still a good ground plane, but a magnet will not inductively through the magnet connect with the ground plate because it's not ferrous. Drill a hole in it. Let me call me over. I'll drill a hole in there and put your your NMO up there, and you'll have a nice ground plane. Solid RF ground connections to the vehicle body and bonding straps between body panels. Have you done bonding straps?
Not in years.
Haven't had to.
Bonding straps are really important at HF. If you're going to run HF out of a mobile, you're going to want to bond your panels. For VHF, UHF, it's not that selective.
Bonding straps between body panels. Mount antenna as clear body parts as possible. I'm not sure why. I don't get that part.
I'm not sure why they want to do that.
I want to mount it as close to the body part called the roof as possible.
Well, if you're hooking it to the fender, you don't want it way down low on the fender because
Yeah.
it's gonna.
That I could get. Okay, nothing was red, yellow. RF grounding and ground loops. AC safety ground is required but not usually adequate for RF. The AC safety ground is at third prong. Additional RF ground is required. For lightning safety, the AC safety ground and RF ground must be bonded together. But do that outside the shop.
Yes.
Don't do that inside. RF grounding, a resonant ground connection can result in high RF voltages on the enclosures of station equipment.
And
Your
that's no
ground
situation-
connection can create a resonance that will be picked up on your equipment. So if you're like getting zapped every time you turn around, you got RF in the shaft. Ground loops. The effects of ground loops can also be minimized by bonding equipment enclosures together. Now, I'm not sure if it's in here, but you do not take this radio and bond it to this radio and bond this radio to that radio and then run over to the bond that goes outside. Each one of them goes to either common ground that then goes outside. The reason is, I believe, because if one of these is disconnected, the one that's not in the circuit could be a problem. I think that's probably why. But bond them also separately to that single point.
Yeah.
It also helps eliminate RF hotspots in the station. Poor RF grounding can cause shocks or RF burns when touching equipment. Grounding all metal enclosures of the station equipment ensures that hazardous voltages cannot appear on the chassis. They're a far better ground circuit than you are. You do not want to be the preferred circuit. Okay, grounding all metal enclosures of station equipment ensures hazardous voltages cannot appear on the chassis. Poor RF grounding can cause distortion of transmitted signals. So if you get that call and it says, hey, you sound really weird, you might have some RF grounding problems. Mobile installations, mobile interference, ignition noise. Okay, that's gonna be up and down possibly with
With
the
RPM.
speed of your car, because you're firing the spark plugs more if you got a electronic ignition and a gasoline motor. Or if you hear that whine of the alternator going up and down, and you won't hear it, the guy that you're talking to will. So you'll hear, hey, it sounds like your alternator. Hey, it sounds like you got a 60 cycle. Hey, it sounds like you got ignition noise. Okay? Noise blankers on modern transceivers are usually effective. They'll take out those pulses. But an alternator is not a pulse. It's just a constant whine. You can't take that out. Diesel engines do not produce ignition noise, but they do produce a lot of noise because they're all computer controlled now. The old style ones probably didn't. Alternator is a high-pitched whine. It's in yellow. Direct battery connections help. And whatever you do, don't cross large cables that have signals going through them. Because what happens when you send a signal across the signal? You got induction, right?
Induction happens.
Vehicle computer, motor-driven devices. Oh, there are people who have reported that when they key up, something turns on or off in the car. Yeah, something's not properly shielded in the car. Windshield wipers. Key up, and the windshield wipers come on. You can determine the length of time that the equipment can be powered from a battery by dividing the battery amp-hour rating by the average current draw of the equipment. Now, that's the information you need to know for the test. In the real world, you need to take everything and convert it to watts to do any calculation.
Yep.
Because amps and amp hours and all of that are totally dependent on voltage. 100 amp hours in my 48 volt battery is way better than your 200 amp 12 volt battery. Because 100 amps in a 48 volt system is 400 amps equivalent at 12 volts.
Well, you got a month's worth of battery?
I got 3 or 4 months worth of battery. I charge about every 3 to 4 months. So, convert it to watts when you're doing your calculations. It just makes things easier because you might be at 13.8 volts and you might be at 12 volts. You need to know how many watts. And that's how you figure out how big of a battery you need to run a certain number of hours.
And that applies even though, like that little switching power supply that I suggested for you, that's a 12 volt, 30 amp power supply. Well, it's really not. It's a 360 watt power supply.
Yeah.
So you turn it up to 13.8, all of a sudden you're down at 26 amps.
Right.
It works. It works. It works fine. But you gotta understand it.
Yeah. You have to. So, building a bus, everybody's like, whoa, I've got 400 amp hours. I'm like, wow, I only have 400 amp hours. Mine's 10 kilowatts. How much is yours? Radio, RF grounding and ground loops. So we're going to use this for a couple. We have a telephone pole. We got some power lines coming in. I'm not sure why this one's not over here. But
Because they're using that as the antenna source.
oh, that's the antenna up there?
Yeah.
Okay, we have a little beam antenna. All right, we got the power lines coming in. They come into the house. Apparently that's the power supply block. There's a ground wire, apparently. Then it comes over the radios and oh look, there's another ground over here, okay? Typical station installation, they say. Lightning hits the power lines way over here. And it comes down and hopefully it goes down there, right? But it's also,
Or it blows out the wall.
it's also coming out here and it's going down there. This is
It's everywhere.
It's going everywhere. But look, they say it in this box, which is your radios. I'm not sure how that is. I think they're just, the drawing's not showing that it went into them. I think you fried your radios. Okay, lightning hits the antenna. First of all, if the lightning hits the antenna, this picture won't be there. It'll be a little puddle of aluminum. Okay? But the power goes down here. Hopefully, you made a 90-degree bend like we're not supposed to, and it couldn't make the corner and kept going. Oh, well, yeah, lightning rescue. But it goes in and it goes and it feeds the power lines. It goes the other direction. So poor RF grounding can cause hum or buzz on a transmitted signal. Could be caused by a ground loop. So if they say, yeah, you got a buzz or it's humming, the SWR reading for one or more antennas goes suddenly very high. It could be poor RF grounding. An item of station equipment starts to draw excessive amounts of current. I'm not sure how that is. Is bleeding over to the ground?
I don't know.
I don't know.
I don't know where that would
It's
come
yellow. They're gonna have a question on it. Or you receive reports of harmonic interference from your station.
That one happens.
All of those. Hum or buzz, the SWR reading for one or more antennas is suddenly high, and item of station equipment starts to draw excessive amounts of current, or you receive reports of harmonic interference.
And you'd see the harmonics on a waterfall, you might not know it.
Right.
Well, you won't see them on your waterfall, because every waterfall I've seen, when you transmit, it doesn't produce anything on the screen. Is your 7100?
Well, if you're looking at someone's signal.
Someone else's signal, yes, yeah. But if you're transmitting, you won't see it on a waterfall. Okay, RF ground and connect the shack ground point to a ground rod. Driven how far to the ground? Until you hit the first rod. Cut it off, dash the end over, so it looks like you drove it all the way. 8 feet is. You use flat wide conductor, so you want to use that strap stuff. I need to get some of that for a training aid. Lowest impedance to RF signals. Flat copper strap is preferred. So that's the stuff that looks like a web belt, kind of. Okay? The really flexible white flat stuff generally goes from your engine block to your frame.
I don't see those anymore.
You know? Flat braid. Flat copper strap, braid. Keep ground wire as short as possible. High impedance if the length approaches a quarter wavelength. It can cause high voltages and RF burns. Why would that be? A quarter wavelength. Why is that significant? Turn into a resonator. No sharp 90-degree bends. I don't get that, but there it is again. Okay, causes RF interference, RFI, radio frequency interference. Fundamental overload, harmonics, and spurious emissions can all cause radio frequency interference. So, fundamental overload, harmonics, and spurious emissions. Okay, fundamental overload on a non-amateur radio or TV receiver by an amateur signal can be reduced or eliminated with a filter at the antenna input of the affected receiver. So if your neighbor comes knocking on your door and says, "You're messing with my TV," that's how you... Okay. What we would do and what they want us to say we would do are two different things. It can be reduced or with a filter at the antenna input of the affected receiver. So Joe the neighbor comes over and, "Yeah, messing with my TV." He needs a filter. Or maybe he just needs to not have his connector loose and hanging out, and it needs to be tightened up. But it's his issue, not yours. But we'll get to that in rules and regs, I think. It might be up here. So what they want us to do is work with your neighbor.
Yes.
You've got to live next to him. The receiver that he has, you can buy a 55-inch TV now for $249 at Weimar. You cannot tell me that that was properly engineered and is of good electronic design. If that's the requirement for that receiver, and if his equipment is not in good engineering, I can't remember the exact phrase.
We'll get to it.
Harmonics. Emissions on an unintended band or frequency. So it could be on the next band over, but it could still be in the same band. Spurious emissions are unwanted radio emissions. So I don't know how they define it. They're unwanted.
Unwanted and
They're
unintended.
Yeah. So I don't know. You key up and it's sending something out on another frequency, and you're yakking on 147.1 to the repeater, and it's sending out something on somewhere else as well.
Spark gap.
You can communicate with a spark plug by putting a jolt to it and sending a spark across. What is the dirtiest signal you'll ever get, and the FCC will knock on the door. They will come find that.
Yeah, Bill said he was first.
He was a kid. He was a kid.
He was a kid, and he had a spark gap transmitter, and he got a letter from the FCC saying he was interfering with the station in San Francisco. And Bill said, "Man, I thought that was really cool. It was getting to San Francisco."
Yeah, nowadays it'd be a black ops team kicking your door in. "Oh, you're not a terrorist. You're a 12-year-old. Oops, sorry." All right, intermodulation. Port contacts between conductors can pick up RF signals. I'm not sure if it tells you up here, but if you've got corrosion in a bolt or a joint on your tower, that can pick up a signal and re-radiate it on the same or another frequency
Yep.
or band. Yeah.
I think that's what's happening with the weather service.
You
Because
think?
they won't-
I believe it, yeah.
I called them on, and they said, well, we don't know how to fix it. I told them, go out and look at your tower and see if there's corrosion.
Yep.
Well, no.
You're the
Their
government.
tower is from
Hire a radio
1932 or
expert.
something. Well, of course it's got corrosion on it.
Okay. Intermodulation combines two signals in a nonlinear circuit to produce unwanted spurious output. Intermodulation and odd order intermodulation products are closest to the original signal frequencies. The odd order intermodulation product of frequencies F1 and F2 is 2F1, F2. I don't remember that ever. That must be a brand new one. And general. The odd order intermodulation product of frequencies F1 and F2 is 2F1 minus F2, or we'll see what the question says when we get to it. Any amateur radio transmitter can cause interference to other nearby devices. Here we go. If amateur equipment is operating properly, the responsibility to fix the problem rests with the owner of the equipment being interfered with. Try convincing your neighbor of that.
Yeah, good luck.
RFI interference. So this is restricted operation. This is part 97. That's why he's handed it out to you. The operation of an amateur station causes general interference to the reception of transmissions from stations operating in the domestic broadcast service. So that's going to be your AM, your FM, and your televisions. The amateur station shall not be operated during the hours of 8 p.m. to 10:30 p.m. local time and on Sunday for the additional period from 10:30 a.m. until 1 p.m. local time upon the frequency or frequencies used when the interference is created. But that is only, this fact is made known to the amateur licensee, okay? However, there's this other part in there that we skipped over. When receivers, that's his gear, of good engineering design, including adequate selectivity characteristics, are used to receive such transmissions. His crap ain't. It was made in China to sell for a nickel on the dollar or whatever, for $259, $249 for a 55-inch TV. It does not meet that criteria. So, best bet, as long as you get along with your neighbor, just try and hook him up. Just check his connections. See if you can put a ugly balun in the signal, in the line. Maybe even a filter. Maybe even buy the filter for him. Depends on how well you get along with your neighbor.
Now, we have an FM station here from the Applegate Christian Fellowships, who's flattering all over all the bands. You remember that, Bruce?
Nope. No.
Yeah, on 40 meters, it was, and you could see it just all across the band.
I've seen some of those lines every X number of kilohertz. Consumer electronics, oh, there we go. See, now I'm not the only one saying this. The slides say it. Oh, wait, I wrote the slides. Actually, I didn't write this. Consumer electronics will rarely meet the of good engineering design criteria. Doing so would increase cost and lose market share to competitors who don't meet the criteria. If something in a neighbor's home is causing harmful interference to your amateur station, work with your neighbor to identify the offending device. If you get along with them, if you don't get along with them, handle it however you want. Politely, there's no law. Your stuff, you can't be interfering with the stuff that's designed for. Politely inform your neighbor that FCC rules prohibit the use of devices that cause interference. Make sure your station meets the standards of good amateur practice before you go and rattle his cage, though. Common mode and direct pickup. Common mode. RF is picked up by external wiring and conducted into the interior of the device. That's called common mode interference. Prevent RF from entering the device. The ferrite choke is your best friend. You can get the clip-ons. You can get the ones that you wrap the wire through. Those generally aren't going to work on your power cords and things because they got big ends on them. But the snap-on ones do. You have to have the right bead. It's not just any old ferrite choke. You need to have the right mixture and composition, they call it, and size. Bypass capacitors might be useful in reducing RF interference to audio frequency circuits.
Notice that specifies audio frequency.
Yeah.
They're right, but it's a restricted use.
It's RF interference to the audio frequency. Direct pickup, RF is radiated directly into the interior of the device. It's difficult to resolve. Harmonics. If the amateur radio equipment is not operating properly, harmonics can appear on the frequency of another receiver. Second harmonic of the 6-meter band falls in the FM broadcast band. Oops. Don't want to do that. Reduce strength of harmonics being radiated by adding a low-pass filter with about the same impedance as the transmission line used between the transmitter and antenna. So what would that impedance be? 50 ohms. 50 ohms. The transmission line, well, there are other transmission lines. So if you're using coax, it's probably 50 ohms. Okay. But whatever the transmission line you're using, because we do have other transmission lines with different, and they are perfectly usable. Okay, fundamental overload. Strong signal from the amateur transmitter overwhelms the receiver front end. So when Matt cranks up his 800 watt, or 800, yeah, no, what is it? Yeah, 800 watt. When he cranks up his 800 watt amplifier 3 blocks away from me. No, hypothetical.
Oh, okay.
The guy was like 3 miles away, and he was
Yeah.
running, 3 miles away, and he was running 800 watts. You know what my waterfall looked like? A big red line. And I'm like, ah! That's fundamental overload. A strong signal from the amateur transmitter overwhelms the receiver front end.
So turn down the RF.
Oh, we're going backwards here. Yes, you turn down the RF gain, you put on the attenuator if you have one, or whatever. Fundamental overload, strong signal from amateur overwhelms the receiver front end usually occurs in nearby TV or AM, FM broadcast radio receivers. Solution is to reduce or eliminate the strength of the signal entering the receiver with a filter on the input. You can attenuate the signal on some radios by hitting the attenuate button. Add high-pass filters to TV or FM receivers, so that's, you're trying to notch them out, get them out of there. Or notch them in after. Add low-pass filters to AM receivers, usually very difficult to do since the antenna is internal on an AM receiver. It's a little bar with wire wrapped around it. Overload of a VHF transceiver by a nearby commercial FM station can be reduced by installing a band reject filter. So band reject filters can see. That, we're just going to stop right here before it gets into the radio. Reduce or eliminate interference to nearby radio or TV. First, be sure all TV coaxial connections are installed properly. So if they're loose or they're running improperly stuck onto the cable, they're probably going to let RF in. Add a filter to the antenna input of the affected receiver. So just right there where his antenna or his cable's coming into his TV. Nearby telephone, put an RF filter on the telephone. RF on shield of the microphone cable. Okay, part 15 devices. An unlicensed device that may emit low-powered radio signals on frequencies used by a licensed service. So, your toaster should have a part 15 FCC certification because electronic device, it's an appliance. Okay, arcing. Any spark or sustained arc generates noise across a wide range of frequencies. That's why Bill, with his spark gap transmitter, got the FCC sent him a letter. That spark just wiped out a whole bunch of spectrum. If you want to jam a spectrum, you get a little electric motor with 4 blades on it and a wire, and you have those blades come by, go spark, 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 and you spin that thing faster and faster, and it's just spitting out all kinds of garbage. It can cause interference with both amateur radio and consumer devices. AC power line noise, nearly continuous crackling buzz. If you have a radio and you drive down northbound is Riverside, southbound is Court. Central.
Court, the other side.
Court.
Okay.
You come down Court Street and you ride around the Trophy Club, you're 146.52.
You will have noise.
It'll go, get louder, and then go down.
We even know which power supply transformer is doing that.
But they haven't fixed it yet. And they're required to do that.
Yep.
Yes, and they're required to fix it. They haven't got to it. Can come and go depending on temperature and humidity. Motors are welders. If you got a buddy next door that welds a lot, you're gonna have some HF.
All bets are off.
You're gonna have some
High
noise.
frequency welders make a spark.
Motors are welders. Noise is only present when offending equipment is operating. Snap-on ferrite chokes. Prevent common mode RF signals from entering the device. Prevent interference generated by the device from being radiated. And for example, you might use a ferrite choke to cure distorted audio caused by RF current flowing on the shield of a microphone cable. So in that case, you're probably going to have a fairly small diameter wire, and you're going to have the right size of mixture.
RF will get into speaker wiring very easily.
Yep.
My wife's stereo on her computer, I had to put ferrite beads on it because she was hearing me talk on my HF radio.
Ferrite bead or core can reduce common mode RF current on the shield of a coaxial cable by creating an impedance in the current's path.